All right, so let's work through a specific little example here. We're given a set of parametric equations, t to the third plus t, x is equal to t to the third plus t, y is equal to 2t plus t squared, and this is from -2 to 4. We're asked to find three things. Number one, dy dx. Number two, the second derivative of y with respect to x both times, and then the equation of the tangent line when t is equal to 0. So let's see if we can play through all this and make sure we know what's going on with this. So number one, this is the kind of things I'll ask of you. Number one, find dy dx. And the short version of this is it's g prime over f prime. And we may write that as, remember, y is given by g, x is given by f. Another way to think of this is this is dy dt, this is dx dt. In any event, it's the derivative of the y definition, g, derivative of g. So the derivative of g is 2 plus 2t over, and then I need the derivative of f, that's 3t plus 1. So that's the derivative. Thanks for coming out. Number two, I want to find the second derivative. So that is, it's the derivative with respect to t of what you just found. 2 plus 2t over 3t plus 1 over dx dt, right? Derivative with respect to t of just t to the third plus t, which is to say it's the derivative of what we just found. It's the derivative of what we just found over f prime again. Each time you find a new derivative, a higher order derivative, you always divide by f prime each time. And so this becomes a stroll down memory lane. We get to use the quotient rule, right? However you learned the quotient rule, denom denom, or low to high, high to low, or did Terry dive on the night man, or however you learned the quotient rule. This is denominator, try that again. Times derivative of the numerator, which is just 2, minus numerator, times derivative of denominator, all over the denominator squared. And then that's all a great big divided by, primary fraction line, the derivative of this, which is 3t plus 1. And then we got if all you're asked to do is find that, there it is. But I think we can simplify this. What does this become? I'm going to do some quick and dirty simplifying here. Distribute the 2, distribute the -3. This gives us 6t plus 2. This gives us -6t minus, -6 minus 6t. So the 6t's cancel, that's -4. This you multiply by the reciprocal, and so I think this works out to be -4 over 3t plus 1 to the third power. So if I distribute it correctly, 6t plus 2, -6 minus 6t, the 6t's cancel, -6 plus 2 is -4 in the numerator. Multiply by the reciprocal and add those exponents. I believe that's the correct value for the second derivative. All right. And then the last piece is we want to find the equation of the tangent line when t is equal to 0. So what I'm going to do is erase this to get a little bit more space to work on. Now, what do I need to find the equation of a tangent line? I need y minus the y value is equal to slope times x minus the x value. And the y value and the x value are the values when t is equal to 0. So if t is equal to 0, that implies that x, well, it implies two things here, right? X is equal to 0 plus 0, and y is equal to 0 plus 0. So when t is equal to 0, this is at the origin. So it turns out that term is 0, that term is 0. All we need is the slope of the tangent line evaluated when t is equal to 0. So the slope is given by the derivative evaluated when t is equal to 0, which is to say it's this evaluated when t is equal to 0. That's 2 plus 0 over 0 plus 1. That's 2. So y minus 0, this term falls out. X minus 0, that term falls out. Slope is 2. All we have is y is equal to 2x. So the procedure is the same. The principle is the same. The different specific way to find the derivatives is what's changed here.